I am very happy to announce that I am going to solve problems from a famous book, Atomic and Molecular Spectra, Laser, written by Rajkumar. Okay, and it's the first chapter. What I am going to discuss, and the name of this chapter is Bohr Somerfield theory. Okay, and the same condition: first read theory, then start solving, and solve problems. Okay, and if you are stuck, come to my channel. Okay, make comment, and I will solve this. Okay, so first of all, I am going to solve these problems. Okay, so this is the Bohr Somerfield theory of hydrogen atoms problems. Okay, so to solve this, you need to know some formulas. Okay, I am going to write some of the formulas. Okay, what you need to know. First of all, okay, if I think you know about the Bohr's model, what the Bohr's model says. Okay, this is the semi-quantum model or semi-classical model, you can say. Okay, when electron minus, okay, sorry, when electron revolves around a nucleus. Okay, when electron revolves around a nucleus. Okay, in stationary circular orbit. Okay, in their orbits, E minus don't radiate energy. Okay, don't. Second postulate is E minus, I mean electron only revolve in those orbit in which angular momentum is integral multiple of h. What is called L equal to nh cut. Okay, Bohr have said this. Okay, and L equal to nh cut, so I can write mvr suman mvr equal to nh by 2 pi. Okay, so you can write this. Okay, and beside this, you need to know one more postulate, that atom radiates only when it jumps from one stable orbit to other. Okay, so from here you can write nu equal to epsilon n minus em by h, where nu equal to the frequency, okay, of the emitted radiation. Okay, so this is the Bohr's semi-quantum or semi-classical model. Okay, in a nutshell. Okay, and the basic parameters you need to know about radius. Okay, radius Rn equal to 0.53 n square by z angstrom. Okay, and velocity Vn equal to 2.18 into 10 to the power 6 z to the power n meter per second, and energy equal to En equal to minus 13.6 z square by n square electron volt. Okay, so these formulas you need to always keep in your mind. Okay, otherwise you can't solve problems. Okay, so I think you all. Now I am going to solve the mathematical problems. Okay, so first problem you can see here. Okay, 1 minute. First problem you can see that the angular momentum of the electron in a hydrogen-like atom is 7.382 into 10 to the power minus 34 joule second. Find the quantum number of the energy level occupied by the electron. Okay, fine. So let's start the problem. First of all, at first I have said always that when electron only revolve in those orbit in which angular momentum is integral multiple of h cut. Okay, so you would know L equal to nh cut. Okay, you can write it. Okay, and after that you can write mvr equal to nh by 2 pi. Okay, and you have already seen that L, the total angular momentum, is given equal to 7.382 into 10 to the power minus 34 joule into second. Okay, so you can see that we need to know about this n. What is the quantum number of the energy level occupied? Okay, so energy level quantum occupied is equal to n. So I need to know about this principal quantum number n. What is the value of n? So n equal to you can easily find 2 pi into 7.382 into 10 to the power minus 34 by 6.62 into, this is nothing but the Planck's constant, into 10 to the power minus 34 joule into second. Okay, so now use calculator and you will get the value of this is 7.0064. So this is the answer. Okay, so it is so simple. And after that I am going to the second problem. The second problem is given that you can see that a hydrogen atom in the ground state absorbed a 20 electron volt photon. What is the speed of the liberated electron? And the energy of the electron in the ground state is minus 13.6 if it is given. Okay, so you need to find the speed of the liberated electron. And I have also told you about the formula that Vn equal to 2.18 into 10 to the power 6 Z by. So you just do nothing, use this formula. So just use this. Okay. So okay. So I am writing this formula. The formula is uh, V equal to 2.18 into 10 to the power 6 Z by n. And I think you all know about these parameters Z, n. Okay, so if you the theory but of this calculation, okay, I'll provide you. Fine. So I think it will be more easier to you if you keep this formula in your mind for okay. If you are preparation for NET, GATE or anything TIF or such type of examinations, you are aspirant of this type of examination, then you need to keep it in your mind. Otherwise, you will feel face difficulties in your exam hall because there you will not get more time to calculate it. Okay, so fine, input the values. Okay, so here you can see that here given that 20.0 eV photon and ground state absorbs 20.0 eV photon, and the ground state energy already have said minus 13.6. So here this energy is already absorbed in this ground state, and this is the ground state energy have already said. So the total energy you will get epsilon n, I mean, so epsilon equal to 20.0 eV minus 30.6 eV. Why minus? This is nothing but the plus minus. Okay, so I think now this is very much familiar to you. Okay, so now 20.0 eV minus 13.6 eV, so you will get 6.4 eV, and from this you can see that the energy is 6.4 eV, so you can find the principal quantum number. Okay, so to minus 13.6 z square by n square, and already said that, and this is the hydrogen atom, so z equal to 1, so minus 13.6 into by n square, and you just substitute this value in this position, so you will get n square equal to minus 13.6 by 6.4. Okay, and you will get n equal to 1.46. so this is your principal quantum number. Okay, now just substitute the value here. Okay, and you already know that z equal to 1, so 2.18 into 10 to the power 6 by n equal to 1.46. Okay, so now you will the useful calculator, and you will get 1.49 into 10 to the power 6 meter per second. So this is the answer. Okay, now I am going to the next problem. You can see the next problem: find the wavelength of the photon emitted when a hydrogen atom goes from the n equal to 10 state to its ground state. Okay, so another formula will be used. Okay, now you will see this, and I think you already have read this, I mean familiar to this formula. Okay, so I'm going to write this formula. You know 1 by lambda equal to this is lambda equal to 1 wavelength. Okay, so this is the wavelength, and R is, this is nothing but Rydberg constant. Okay, I will provide you the value of the Rydberg constant. Okay, R is, and 1 by n1 square minus 1 by n2 square. Okay, so I think this is the formula. Okay, from where I got this formula? Okay, so when an atom jumps from one level to another, okay, so this is one level and this is another level. So when the atom, this is I think n1, this is n2. So when atom jumps to one level to another, okay, then I think if you think that n2 equal to n1, where n2 greater than n1, okay, then this kind of for this kind of jump, the absorption will be happen, and for if you think this is n2, this is n1, n1 and n2, and this type of emit radiation will emit. Okay, so I think you know this, and from there I have got this formula. Okay, so if you does nothing but just some mathematical calculations. Okay, you just sorry. So here already you have seen that here atom goes n equal to 10 state to its ground state. Ground state mean n equal to 1. Okay, so always keep it in your mind. So R is into 1 by 1, because n equal to 1 minus 1 by 10 to the power square. Okay, so you will get this. Okay, now you need to know the wavelength. Okay, so value R is equal to, this is the Rydberg constant, 109737 centimeter inverse. This is the value of the Rydberg constant, and if you write it in meter, I mean in case, then 1.097 into 10 to the power 7 meter inverse. Okay, so and then you will get 1.097 into 10 to the power 7 into if you clear this, then you will get 99/100, and this will be 1 by lambda. And if you use calculator, then you will get lambda equal to 920 angstrom. This is the angstrom. So enough for today. I have already solved 3 problems, and after that I will go forward. And if you think the video is useful, then kindly subscribe my channel and share with your friends. Okay, thank you.